Welcome to NMK online lessons. Today we are going to learn mathematics and we'll look at trigonometry. Under trigonometry, let's look at the trig ratios. Trig ratios. Okay? Trigonometric ratios helps us to understand the relationship between the angles and the sides of the right triangle. Trigonometric ratios, we have what we call the sine, we have cosine, and the tangents. Okay? We have the sine, we have cosine, and the tangent. We have the formula that can help us, there's a formula that can help us to remember the trig ratios. Okay? And this formula is what we call the SOHCAHTOA. SOHCAHTOA. Where AC simply stands for sine, O stands for opposite, H stands for hypotenuse, then C here cosine, A adjacent, hypotenuse, T there stands for the tangent, then O opposite, and A the adjacent. Let's say I have my right triangle here, and let this be my right angle, and this be my angle theta. Okay? So if I'm to use sine, then I know that I'm going to have sine theta is equal to O, which is opposite. This simply means the side which is opposite to this angle, and the side which is opposite to this angle is simply this side here. Okay? So this side is opposite to that angle. So say sine theta is equal to opposite, okay, over the hypotenuse, which is this side there. So over the hypotenuse. Number 2, cos theta. Cos theta is equal to, if you look at the way it's SOHCAHTOA, we have this part, C, which simply means cosine, A adjacent, and H hypotenuse. So cos theta, okay, we are just going to say A, which is adjacent, which side is adjacent to this angle, and the side which is adjacent to this angle is simply this side here. So say cos theta is equal to adjacent over the hypotenuse. Okay? Number 3, tan theta. Tan theta is equal to opposite over adjacent. Which side is opposite to this angle? This one there. Then adjacent is that. So tan theta is equal to opposite over the adjacent. So these are the trig ratios. These are the trig ratios that can help us, okay? These trig ratios can help us to understand the spatial angles. The trig ratios can help us understand the spatial angles. We've got other trig ratios. Okay? We have what we call the cosecant. We have cosecant, which we can also call the cosec. Okay? That can also be called the cosec. We also have what we call the secant. Secant. Okay? We can also call this one as the sec. We also call we also have what we call the cotangent. The cotangent. This one can be called the cot. Okay? So we have cosec, we have sec, and the cot. If you look at cosec, cosec goes with the sine. And if we are saying that sine is equal to opposite over hypotenuse, then we know that our cosec theta is going to be hypotenuse over opposite. Hypotenuse over opposite. And if you go to the second one, which is the second, or sec. So if you say sec theta, sec theta is equal to, this sec goes with the cosine. So if we say that cosine is equal to adjacent over hypotenuse, then our sec theta is going to be hypotenuse over the adjacent. So say hypotenuse over the adjacent. Okay. And the last one, we have the chord. So this chord goes with the tan. Okay? Chord theta is equal to, since tan theta is opposite over adjacent, then our chord theta is going to be adjacent over the opposite. Okay. So these ratios helps us to understand the trig identities. Okay? We are going to look at the trig identities, I'm sure, in my next video. So, cosec theta is equal to hypotenuse over opposite, and sec theta is equal to hypotenuse over adjacent, cot theta is equal to adjacent over opposite. So these guys here help us to understand the trig identities. Now let's look at what we call the special angles. Let's look at the special angles. Let's look at the special angles. Special angles. So these special angles, we have the 30 degrees, 45 degrees, and the 60 degrees. Okay? Let's look at it. This is 30 degrees, 45 degrees, and the 60 degrees. You know, when we are dealing with the trigonometry, there are just some things which you should just know. For example, if they tell you that find sine 30 degrees, this one you should just know it by heart. Okay? Cos 60 degrees, tan 45, those you should just know them. Okay? So sine 30, we know that sine 30 is equal to 0.5. Sine 30 is 0.5. And we know 0.5. 0.5 is equal to 1 over what? 1 over 2. And if we are saying that sine theta is equal to opposite over the hypotenuse, and we are saying that sine 30 degrees is equal to 1 over 2, then I know that, okay, my opposite is going to be 1, okay, and my hypotenuse is going to be 2. If I am to draw let me draw my right angled triangle, and let this be the 90 degrees there, and this be my 30 degrees. Okay? Let this be 30 degrees. If I have 90 here, 30 there, then I know that this is going to be 60 degrees. Okay? This is going to be 60 degrees. Okay. So now, if you are saying that sine 30 degrees is equal to 1 over 2, and we are saying that sine theta is equal to opposite over hypotenuse, then I know that 1 is equal to the opposite, okay? The opposite of this angle. I'm sure this is clear. Also, my 2 there, 2 is equal to what? The hypotenuse. Then I'll simply say, since I'm saying that 1 is equal to opposite, and I look at this angle, which side is opposite to this angle? It's simply this one. Then automatically this side is going to be what? It's going to be 1. And the hypotenuse is simply this length here. Therefore, I'm going just to put it to there. Okay? So for me to find this length or to find the value of this length, then I can use the Pythagoras theorem. Okay? We can use the Pythagoras theorem to find this side. So let's use Pythagoras theorem to calculate this side. We know that since this is my hypotenuse, then I know that I'm going to have 2 squared, which is equal to what? 1 squared. And since this side and this side are adjacent to 90 degrees, then I'm going to add these 2. Okay? So 1 plus, let me name this side as my A. Then I know that 2 squared is equal to 1 squared plus A squared. Okay? This will give me what? I know that A squared is going to be 4 minus 1. Then A squared is equal to 3. To find the value of A, then I should introduce the square root both sides. So this side and the other side. Then I know that this square and the root there will go. I will remain with A is equal to root of what? Root 3. Okay? And let me put root 3 where there is A in my right triangle. Then I know that this part is going to be root what? Root 3. Okay? So now let me try to find sine 30, cos 30, okay, and tan 30. So sine 30, we'll begin with sine 30. Sine 30 degrees. So my sine 30 degrees is going to be sine 30 opposite over the hypotenuse. Then I'm going to have 1 over 2. So sine 30 is equal to 1 over 2. Number 2, cos 30 degrees. Cos 30 degrees. We know that cos, okay, cos theta is equal to adjacent over the hypotenuse. Then I know that the side which is adjacent to this angle is simply that root of 3. Then cos theta is equal to root 3 over the hypotenuse which is just in 2 there. So my cos theta is equal to root 3 over 2. Number 3. Okay. Number 3, let's look at tan 30 degrees. Tan 30 degrees. We know that tan theta is equal to opposite over the adjacent. Okay? So now, which side is opposite to this angle? We know that is 1. And which one is adjacent? We know that is what? It's root 3. Then I'll simply say tan 30 degrees is going to be 1 divided by what? Root of 3 or root 3. We can rationalize the denominator here by simply multiplying by root 3 over root 3. If I say 1 times root 3, what are you going to have? You are going to simply have root 3 divided by root 3 times root 3, you get 3. Therefore, tan 30 degrees is equal to root 3 over 3. Okay? We are done with the 30 degrees. Let's go to, and since I have 60 degrees here, let me also just tackle this one, okay, before we look at the 45 degrees. Let's look at 60 degrees. Let's begin by sine 60 degrees. So if we say sine 60, then I know that we are going to get the opposite side of this angle, which is root of 3 divided by the hypotenuse. So we have sine 60 degrees is equal to which side is opposite? It is root 3 over the hypotenuse, which is simply 2. So we have sine 60 degrees is simply root 3 over 2. We go to cos 60 degrees. Cos 60 degrees, we know that is 0.5, and that is 1 over 2. So if we are to come on our right triangle, we are going to find that if we say cos 60 degrees, and we know that cos theta is simply the adjacent, which side is adjacent to this angle? It's simply 1. So we say adjacent, which is 1 over the hypotenuse, which is simply 2. So we know that cos 60 degrees is just 1 over 2. Okay. So we'll go to tan 60 degrees. Tan 60 degrees. If you look at this triangle, we know that tan theta is simply opposite over the adjacent. Which side is opposite to that? Is root of 3. So we are going to say tan 60 degrees is simply root of 3 over the adjacent side, which is 1. So if you say root of 3 divided by 1, we are simply going to have, okay, let's say tan theta, okay, tan 60 degrees is simply root of 3. Root of 3. Okay. We are done with 60 degrees. Now we can look at 45. Maybe let me put them here. Okay. Let me just put them somewhere here. Let me begin with sine 30. You know that sine 30 degrees, this is equal to 1 over 2. Then we have cos 30 degrees is equal to what? Root of 3 divided by 2. Then tan 30 degrees is equal to root of 3 divided by 3. Very important. Okay? These are very much important in trigonometry. Okay? If we look at sine 60, okay? Sine 60. So we say, let me divide this. So sine 60 degrees, this is just root of 3 over 2. Root 3 divided by 2. Then cos 60 degrees, this is simply 1 over 2. Okay? Then tan 60, let me just get some pieces of chalk. Okay. So tan 60 degrees, this is simply root of 3. So make sure that you know these things. Now let's look at 45 degrees. Let's look at 45 degrees. Okay? 45 degrees. Okay, let me say that this is let's say this is my right triangle, and let this be my 90 degrees. And if this is 45 degrees, then I know that this one also will be 45 degrees. If I have 45 degrees there, I also have 45 degrees there. Then I know that the length from this point to that point is equal to the length from this point to that point. Meaning, if I have one here, I'm going to have one there. Okay? So for me to calculate the hypotenuse, I can use Pythagoras theorem. Okay? So that, let me name this as my h. So that I'm going to have h squared is equal to what? Is equal to 1 squared plus 1 squared. What do I have? I have h squared is equal to what? 1 plus 1. You are going to have h squared is equal to 2. To find the value of h, we just simply introduce the square root both sides. Then you know that your h is going to be the root of what? The root of 2. Okay? Meaning this is our hypotenuse. So I'm going to replace, okay, this h by the root of 2 there. So I'm going to remove this h, and I know that this one is simply the root of 2. Okay. So if you are to use sine, let's say sine 45 degrees, sine 45 degrees. Sine 45 degrees is equal, remember sine, opposite over hypotenuse. So opposite, which is 1 over the hypotenuse is simply the root of 2. Rationalize the denominator. You are going to have a root of 2 divide by root of 2. So that you are going to have sine 45 degrees is equal to 1 times root of 2, you get root of 2. Divide by root of 2 times root of 2, you get 2. Okay? So this is the value of sine 45 degrees. Let's try to go for cos 45 degrees. Cos 45 degrees. Okay? Cos 45 degrees. We know that cos, okay, you can find cos by adjacent divided by the hypotenuse. So if we say cos 45 degrees, which side is adjacent to this angle is simply 1. So we simply say cos 45 degrees is 1 over the what? The hypotenuse, which is root of what? Root of 2. We rationalize the denominator, we are going to have root of 2 over root of 2. Okay? So that if you say 1 times root of 2, we are going to have, okay, cos 45 degrees is equal to root of 2 divided by root of 2 times root of 2, we are going to get 2. Okay? So this is the value of cos 45. So cos 45 and sine 45, they are just the same. If you want, you can get a calculator and try to enter sine 45. You are going to find that you get the same values with the cos 45. Okay? Let's look at tan 45 degrees. Tan 45 degrees. Tan 45 degrees. If we say tan theta, okay, tan theta is simply opposite, okay, the opposite side to the angle over the adjacent side. Now, if you look at this angle, which one is opposite is 1, adjacent is 1. Which simply means we are going to divide 1 by 1, and we'll just get 1. So, in short, we can simply say tan 45 is simply 1 there. Okay? Or maybe let me just show it. Let me show it. So we are saying that the opposite, which is 1, over the adjacent, which is also 1. 1 into 1, that is 1. Therefore, tan 45 degrees is equal to what? 1. Okay? You can try to put it on the calculator and find that tan 45 degrees is just 1. Thank you so very much. Today, just sort of, looking at the trigonometry.